Okay, this video is about what is the difference between animal and plant proteins. There are major differences between animal and plant proteins, and it starts out with the package they come in. The animal proteins are surrounded by tons of saturated fat, which is bad. The more fat in your diet, the fatter you get. There's no fiber in animal foods, so you get constipated, and that causes all kinds of intestinal problems. There's almost zero antioxidants, so this weakens your immune system to not have those antioxidants, which help to remove all the reactive oxygen species and minimize oxidative stress. So meat comes in a bad package. Then there's a higher overall protein amount, and you really don't want all that protein. It puts extra work burden on your kidneys, and it has a growth hormone-like effect, especially because of the amino acid composition of meat. A good meat to remember is salmon. Salmon's about 50-50, 50% fat, 50% protein. And other meats tend to vary around that. There's no carbohydrate in meat. Now, beef is about 45% fat and 55% protein. Chicken, if you fry the beef, it's going to be higher in fat. Beef's about, lean chicken. Lean chicken can be about 25% fat, about as low as it's going to get, and 75% protein. These are terrible foods because I want my dietary protein and dietary fat below 10%. I never count it. I just know by what I'm eating if it's going to ballpark down there. A general whole food plant-based diet tends to have a person end up about 80-10-10. 80% carbohydrate, 10% protein, 10% fat. And then the persons who try to really optimize it a little more will end up getting their fat and protein even a little bit lower. Now, most forms of meat are high in all the essential amino acids. Lysine, leucine, and methionine are the main ones that come up. Tryptophan sometimes comes up as well. The other thing about the meat, it also has increased heme iron, which I consider a bad thing because, men in westernized countries tend to be iron overloaded after 20 years of age. Women when they're postmenopausal. So I don't want that extra iron. And heme iron is more heavily absorbed. Okay, the main essential amino acids that we care about are leucine, lysine, methionine, and to a lesser extent tryptophan. Now, when you look at plant protein, it comes packaged with good things. Lots of fiber, good bowel health, antioxidants, improving immune system function, and it's very low in fat most of the time. There's some exceptions like with avocados and nuts and seeds, but in general, plant foods are quite low in fat. They're lower in overall percent protein. Now look at the percent protein numbers here. Sweet potatoes are the healthiest food in the whole world, 4.5% protein. Rice, only 5% protein. Rice is a fantastic food. Those Asians, when they were eating 80% or more rice, they were having some of the longest lives of anyone in the world. Look at Japan. Even though they smoke like crazy and put tons of salt on their food, they were still like the healthiest people in the world after the Seventh-day Adventists, okay? That's rather incredible, not to mention the Okinawans. All right. Potatoes, about 9% protein. That's still pretty low. Corn, about 10% protein. Look at those Kenyans. They're the best runners in the whole world, and they eat tons of corn. Okay, oatmeal, also a good food. A little higher in protein here in quinoa. Beans are the highest plant food in protein. Beans have, about typically in the ballpark of 25 to 30% protein. Soy has even more protein than that. Grains and beans tend to be low in vitamins and omega-3s, whereas the greens tend to be very high in vitamins and in omega-3 fats. It's a little bit of a side issue there, maybe a topic for another talk. Okay, so now we're going to get to the money. Grains are low in lysine, and you can make a mnemonic. G for grains, L for lysine, low, and it's just like glow. Grains low. Okay, that's how I remember that one. Methionine, they can be a little bit low in methionine, not as much as beans are, but they sometimes are. It depends on the type of grain. Rice is quite low in lysine. All right, so remember, grains low in lysine, glow. All right, corn's low in tryptophan, kind of a unique thing to do with corn, but it's relatively higher in methionine and leucine. And this is all going to get to something else important coming up, in a little bit. Sesame seeds really high in methionine. So that might be something a bodybuilder wants. A bodybuilder might want accelerated growth, accelerated cell division. So they could do something like combine sesame seeds being high in methionine with chickpeas or something as a way to accelerate growth for someone who'd want to do that. A 20-year-old bodybuilder wants accelerated cell division and growth, but after 30, especially after 40, you don't want accelerated replication, speeding up potentially cancer growth, speeding up potentially the rate at which you reach the Hayflick limit, the maximum number of cell divisions, usually about 60 for a somatic cell, meaning not a germ cell, meaning not ovary or testes. and not a stem cell. So accelerated reaching of the Hayflick limit is thought to cause accelerated aging. Okay, next thing, beans. Beans, are low in methionine. They tend to have relatively increased amounts of lysine and leucine, not quite as much as meats, but moving in that direction, and they're low in methionine. Okay, green leafy veggies tend to be higher in both methionine and lysine. It's just that people don't eat as much greens and they don't have that many calories. So when you talk about percent of calories, it's relative to a small number of calories. Okay, now as far as how much protein do people need, we've had previous lectures on this subject, but basically milk, human breast milk's about 5 or 6% protein, depending on what you read. And, the Papua New Guinea's really healthy. They were only eating 4.4% calories from protein because they ate almost most of their calories, over 93%, from sweet potatoes. All right, so the point of all this, and there's even people like starving, and they just feed them 2.5% of their calories from protein. This one paper by a guy named Golden. And so that's my point. We really need hardly any protein, okay? And about the lowest you could possibly eat would probably be in the ballpark of around 4%. Kempner used to feed his patients about 4% protein and had incredibly good results for their health. All right, so what I'm trying to say is anything you could possibly eat of whole food plant foods, you could never be too low in protein. You could never be too low in fat. Those things are non-issues. And that's important to realize because, the typical ignorant person thinks, got to get my protein, got to get my good fats. No, those are the last things to worry about. Okay, now here is a paper characterizing the muscle anabolic potential of dairy, meat, and plant-based proteins in older adults. Okay, so here's the reference to the paper, and it talks about plant proteins in general, lower in leucine. And leucine, you don't want more leucine. Leucine is what activates mTOR, the nutrient sensing pathway, like a building contractor getting ready to build a building. It wants to make sure it's got leucine, lysine, and methionine, then it can build. Okay, so if you got less of those amino acids, the thought is that can potentially slow down cancer growth. Okay, animal proteins are more anabolic than plant-based protein. That's why bodybuilders are going to want more of those anabolic proteins, especially the branched chain amino acids like leucine, for example. Theoretically, the lower anabolic capacity of plant proteins can be compensated by ingesting a greater dose of protein, like in beans, or by combining the various plant-based proteins to provide a more favorable amino acid profile. So the point is, if you're eating a bean that's low in methionine, and then you eat that with a grain that might be low in lysine, together you might get as much of those amino acids as your bodybuilder person might want. But that's going to raise a question. What's the smart thing to do if you got cancer or you're older and you're worried about cancer? Now here's from the same paper showing some of the numbers. So this is for lysine, and here's plant foods, here's animal foods. Okay, so you look at the lysine in wheat, quite low, 1.4. We'll just call it 1.4 units relative to some standardized number of calories. Then you go to at a similar on beef, 9.3. So multiple times more lysine in beef, animal product. Whereas some of the things like the peas, which is a legume, we're going to consider it, and soy, they're going to have a lot more lysine, but they're going to be quite low in methionine. That's what we're talking about. But one thing to keep in mind too, a food like potato is relatively low in protein. That's about 8.5–9% protein, whereas soy is going to be much, much higher in protein. And take a look at rice. Rice is super low, only about 5% protein. So you're just going to be eating a lot less protein with food like this. Rice and oatmeal might have similar percentages of lysine, but rice has a lot more protein than does oatmeal, for example. Okay, now here's what I think is one of the coolest slides. And this is from this paper, Nutrient Value of Leaf versus Seed by Edelman, 2016. So here's what I'm getting at. This is a graph showing the amount of lysine, percentage of calories, and here it is the amount of methionine, percentage of calories in the protein from these different foods. And the worst of both worlds is these animals. All the stuff in red right here are animal foods, and I call this the cancer kill zone. High in methionine, high in lysine. That seems to be the perfect blend to accelerate cancer growth. And look, that's where all your animal foods are. What's his name? T. Colin Campbell, in his book here, the China study, he was able to turn cancer on and off in rodents, either with hepatitis B virus, which affects the liver, or with aflatoxin, a carcinogen from moldy peanut butter, which affects the liver. And basically, if he gave them 5% protein, they wouldn't get cancer. 5% casein, the milk protein, versus if he gave them 20%, they all would get cancer. Okay, so that's an interesting paper. I'm going to talk about this book and that paper in subsequent videos. But what I'm trying to show you here is you can't win with the meat. You're screwed. Okay, you're way high in lysine, you're way high in methionine. You got no antioxidants, you got extra heme, you got no fiber. It's like everything bad towards making you sicker and more likely to have cancer. The beans alone are over here because they're low in methionine. The grains alone are over here because they're low in lysine. So, all right, and so like I kind of shown this picture before in other talks, but what we're trying to do is get everything good. And another thing, I'm going to talk about this in future lectures. I'm just whet your appetites here that, you know, it's been said, oh, it's the same diet that's good for everything. I'm actually going to disagree with that a little bit. And I actually think this is one of the things that's different than me about other nutrition experts is I'm not just interested in, you know, having clean coronary arteries. Esselstyn's diet is the best, okay? You eat a very low-fat, plant-based diet, whole food, no oil, no meats, no sweets, no caffeine. You're going to keep your coronaries clean. But as I've added to that, I don't want to just keep my coronaries clean and my brain arteries clean. I want to minimize things that increase metabolic demand in my brain neurons to decrease my risk of dementia. That's why I avoid MSG. I'll avoid excitatory amino acids like aspartame, all right? Because aspartate is also an excitatory amino acid like glutamate. In addition, I'm going to avoid the toxins that are in non-organic foods. That's why I'm only going to eat organic, because I think that protects the brain. And you keep hearing how great beans are, but I'm going to tell you something. I haven't figured it out, and I don't want to say anything definitive because I don't know enough to say anything definitive, but the more I look at this protein stuff, there's a major question in protein nutrition that is not well answered, and we'll talk about that in a future talk. So anyways, hope this is helpful.